One fine morning, you flip a light switch and notice a lovely popping sound, accompanied by a brief blue flashlight from within the switch. If you think deeply, you will be amazed by the fact that spark is occurring in air. Let's figure out a physically reasonable mechanism for the creation of sparks in air. I promise there won't be any intricate mathematics involved here. Let us start with a simple experiment. Two metal balls, one negatively charged and the another one positively charged. When these two balls are brought close to each other, we observe a spark in air. Now what we will do is that we will try to explain this observation. That is, how can such sparks occur in air? We will try to answer this question. In order to do so, we will take help of three fundamental questions. Number one, how can electric charge move through air? Number two, why does a spark last only for a very short time? Number three, why do we see light? Let us take up the first question. How can electric charge move through air? Before jumping into any kind of conclusion, let us look at the figure. Can you take a guess? You might be tempted to guess that the electrons could simply jump from the negatively charged ball to the positively charged ball, since the metal balls are close enough. But this does not happen. Why? Because air is an excellent insulator. Let's invest some more time in our guesswork and see why it is not feasible. Let's say an electron comes out of the negatively charged sphere and it wants to go to the positively charged sphere. Now what will happen? This electron will suffer several collisions with the air molecules, that is the nitrogen and the oxygen molecules, and it will lose much of its energy. As a result, this electron will not reach the positively charged ball. Okay, so our guess did not work. So what we will do is that we will take help of an assumption. Let us assume that by some means the air between the metal balls become ionized. Air would now contain both free electrons and positive ions, that is N2 plus and O2 plus. It can now behave as a conductor because it has got a sea of charge carrier. You might be thinking how the air became ionized. Don't worry, stay with me. We will take up this assumption at the last part of the video. Now, let's move forward with our assumption. Based on our assumption, now the medium contains number 1, free electrons, number 2, positive ions, that is N2 plus, O2 plus, etc. etc. Since the metal balls are close enough, there is a strong electric field in this region. Under the influence of the electric field, the free electrons move towards the positively charged ball, that is opposite to the direction of the electric field, and the positive ions move towards the negatively charged ball along the direction of the electric field. Since there are a very large number of charged particles near each ball, the charge carriers move only a very small distance to supply adequate charge to neutralize both the balls. This brings us to the next question. Why do we observe spark only for a very short time? The free electrons which are present near the positively charged metal ball feels an electron deficiency in the ball, making the ball less positively charged. The positive ions pick up excess electron from the negatively charged metal ball and the ion becomes an ordinary neutral air molecule. The negatively charged ball is now less negatively charged. Due to this, the magnitude of electric field at all locations, obviously between the two metal balls, decreases. After a very short period of time, the electric field decreases below a threshold value, which allows the positive ions and the free electrons to recombine. Due to this recombination, the number of charge carriers in this region decreases considerably. The gas is no longer a conductor and the spark stops. Now, let's deal with the final question. That is, why do we see light? This is quite simple to understand. When a free electron and a positive ion recombine, they do not directly form a bound state. Initially, they form a high energy unbound state. Its lifetime is very less. After a very short time, there is a transition from the high energy unbound state to a low energy bound state. During this transition, a photon is emitted. And now you know why do we see light. Although the light that we see is the most obvious aspect of a spark. In other words, we identify a spark by the light. But the light can be considered to be essentially a mere side effect of conduction in gas. Now, all the three fundamental questions are answered and you know the reason behind the occurrence of spark in air. But one thing is still left, if you remember. That is the assumption. You must have heard about the cosmic rays. These cosmic rays, while entering the earth, interacts with the upper layers of the atmosphere and generates extremely fast moving charged particles, such as negatively and positively charged muons. As the rapidly moving charged muons plunge downward through air, they have enough energy to occasionally knock electron out of air molecules, producing free electrons and positive ions. Wait, there is a catch over here. The number of free electrons and ions produced by cosmic ray muons is much too small to make the air be a good conductor. Since the number is very small, the air remains an insulator. This is where the magic happens. This is the point where the electric field comes into play. The electric field present in the region between the metal balls make these free electrons accelerate. These electrons now have sufficient energy to knock out further electrons from the neutral air molecules. And a chain reaction starts, making the air ionized. I believe you have enjoyed this video. Keep learning.